Okay, this is Geometry, Chapter 1, Section 2. This is the vocabulary here. If you want to take a moment and pause the video, you can copy down your vocabulary words with definitions, and I'll come back in just a minute and describe them each. Okay, let's start with a discussion on precision. Precision, as we defined it, was a measurement to be within 0.5 units of what you're measuring in. So what does that mean? Well, if we look at this ruler here, and we've got our line, and PM would be a segment because it's got endpoints. And if I start and put my ruler on 0 on the P, then I'm going to come over here and I'm going to look and see where my M is. Well, it's got the big lines, which are centimeters. It's got these little bitty lines, which are millimeters. So that means I can measure to the closest millimeter. So if I come down here and I look, it looks to be about 71 millimeters. So I'm guessing 71 millimeters. But I could be off by up to 0.5. So I'm going to take the closest to the closest half. So it might be 71.1 millimeter. This might be 71.2 millimeters. It might be 70.8 millimeters. I don't know. But I'm going to call it 71, and hopefully I'm within a half a unit. If that didn't make sense, let's look at another example. So down here, I've removed the millimeter marks off my ruler here, and so all I've got are my centimeters. And you can see that this B, point B, end point B, is somewhere between 4 and 5. And we're not sure where. Precision means I need to be within the half unit. So that means I should be able to figure out if this, we're going to call this 4 centimeters or 5 centimeters, based on am I over or under this halfway mark. Since I think I'm just over 4, I'm going to call this 4.5 centimeters, or I'm going to call it 5 centimeters. And that would be within a half a unit. Now I could make this larger. Or smaller. Okay? And based on where I put it, so if I'm right here, I know I'm really close to 5 centimeters. Here I'm close to 5 centimeters. Here I'm close to 5 centimeters. Here I'm close to 5 centimeters. But then up here I'm going to say it's closer to the 6 centimeters. And down here I'm going to say it's closer to the 4 centimeters. So what am I closest to based on halfway between two of the lines that I'm measuring to? So that's what precision is. How about betweenness? Okay, with betweenness, we're saying that this point Q is between P and M. But this point T is not between P and M because it's not on the same line. Now your book uses words like collinear, co, on the same, linear line, on the same line. So if I put T down here, T would be between Q and M. It also would be between P and M. Okay? If I put it over here, it would be between P and Q and between P and M. But if it's off my line, it is not between. Even if I'm really close here, it is still not considered between unless it is on the line. The other part of the definition is this distance from P to Q and this distance from Q to M. When you add them together, you should get the distance from P to M, and that should make sense. So if this distance here were 3, and this distance here were 3, then the distance PM would have to be equal to 6. Okay? Likewise, if I, put T on here, the distance from Q to T, and if I said that was 1, and the distance from T to M, if I said that was 2, then the distance from Q to M would have to be equal to 3 because those would all have to add up. So that's what betweenness is. Betweenness on the line, and then the distances have to add up. Absolute error and relative error. So this one's kind of a little obscure. You don't use this very much. It does show up in this section, so we'll cover it here. Absolute error. You're going to take your actual measurement using our precision. So I'm going to call this 5.5. Okay, so actual measurement 5.5 centimeters. My allowable measurement. This could be as much as, if I'm off, I could have made it 5.55 centimeters, and that would have been okay. Or if we want to change this to millimeters, you can do millimeters. Okay. Remember, I'm allowed to be off by half of whatever I'm measuring to. And I think I'm going a little bit above, not a little bit below, so that's why I'm subtracting this way. And it's the absolute value of this, so the absolute error on the top would be 0.05. Okay. And then I would have my line. And the actual measurement, I said the actual measurement was 5.5. And that would be equal here, and another equal sign here. And then you grab your calculator. Okay, and so I'm going to take my 0.05, and fraction lines mean divide. And I'm going to divide by 5.5, and that's going to be equal to 0.00909090. Okay, so 0.009090. And we're going to take this and make this as a percent, so I move my decimal 2 places, 1, 2, so I end up with a 0.1% error on this. Okay, so again, I take my actual measurement, whatever it happens to be, and I measure this as 5.5 centimeters. I take my allowable measure, so I put on that 0.5, or I could take off the 0.5, wouldn't matter. When you subtract, you still get that 0.05. Divide it by your actual measurement, that was at 5.5 again, and then change it into percent. So I could be off by 0.1%, and that would be an allowable relative error for this problem. And the last thing to talk about is the idea of congruence here. So two segments have the same measure, they are congruent. This is going to show up all year long. You're going to be using the definition of congruent throughout the entire year, so please know this one, this is important. This is the symbol for congruent. It's an equal sign with a little squiggly on top, so you can type an equal sign and then grab your pen and put a squiggle over it, or you can go and put in symbols for the congruence, but that's basically your congruent symbol. And it means the distance from x to y is the same distance from p to q. They are congruent, they are the same length. The little red dash here, you're also going to be seeing those all year long. The little red dashes mean the same length or congruent. So anytime you see a dash on two segments, you know they are the same length.